All right, welcome back. I hope you guys had a nice weekend. So your warm-up are, what are the 3 transformations that we've talked about so far, okay? So we've talked about 3 different types. See if you can name them for me, okay? Today we will look at what are called dilations. Dilations, are keeping the shape of an object but making the object bigger or smaller. We do this by multiplying by a scale factor, okay? So if you wanted to, say, have a square that was like a 2 by 2 square, and then make it bigger, but have the same type of object. So if I still want a square, I could multiply both sides by 2 and then get a 4 by 4. Or I could multiply both sides by 3 and get a 9 by 9 square. These are all 3 squares. Mind you, my drawing's not awesome, but we're pretending they're all squares. And they're all multiplied by a scale factor to get to one another, okay? So it's keeping the object the same, but changing the size of the object, okay? And a scale factor, all it is the distance. So this is a fancy term. We're going to go over a more specific term that's going to help you. It's the distance from the center of dilation to the image over the distance from the center of dilation to the original, okay? Now that is a very, very technical definition there. We're going to talk more about the scale factor and how to find it in some of our examples, okay? So if that does not make sense, that's okay, all right? So here's just a picture. If you look at the painting, so hopefully yours shows up a little bit better, but we can see this painting here, and this is the painting portion of it, okay? This inside square, and the outside square is the frame, right? You've all seen pictures with frames. So you can see the actual picture in its frame. The frame is a dilation from the picture. So here's the center of my picture. Both objects are rectangles, but of just different size, right? The center of dilation is the center of the picture. So from here to here, that's the dilation. This is my center of dilation. So I can see that this here is going to be my bottom length, my bottom number of my fraction. This longer length would be the top number of my fraction, okay? Just so you can kind of see that kind of thing. Now when you dilate something, it has to have some sort of center point. So in our picture, it's this very middle of the portion. If I look at this object though, notice this is my center point down here. Because each point, so like my A and A prime, they lie on this same dotted line that's touching the center. B and B prime are on the same line touching the center. C and C prime on the same line that touches the center, okay? So I know I'm doing a lot of talking and background information, but that's just so you can better understand dilations, okay? And again, that's just what this note does say is, notice that each point in its prime lie on the line and the center point, okay? So the dilation, if I start with this object and want to make it bigger, the next point has to lie in this line. And if I wanted to make it even bigger, I would extend these lines, and eventually the A double prime, B double prime, and C double prime would also have to lie on all these lines in order for it to be a dilation, okay? So this is a picture from your book. The question is, which triangles are actually dilations of each other? So if you look real close here, let me zoom in a bit. I have the triangle ABE, which is this lighter red triangle, which you probably won't see it in red, but mine's red. And then I have a bigger triangle ACD, and then I also have this one off to the side, FGH. So the question is, which ones of these are dilations of each other? And remember, in our last example, I told you it has to lie on the same line with the center, right? The A prime and B prime, then it's original. So if I look at this, triangle here, FGH doesn't lie on the same point with my bigger triangle, right? Or even my smaller triangle. Some of them lie on the same point, but not all of them, right? So this triangle is not a dilation of either of my other triangles. This one is, right? Because C and A lie on the same point. I'm sorry, actually C and B lie on the same point, right? A is on the same point because we're using it twice, and then D and E lie on the same line, right? Okay. So I can see if I were to draw a line through them, this goes through a line, this goes through a line, and A is actually my center, right? Because it all goes through this line to the center. Okay. It just happens that A was my starting point for all of them. Okay. So if there's a dilation, if they ask you, is this a dilation of it? They have to lie on the same line, and it has to get bigger by a scale factor. So notice that this side is 1, 2, 3, And this big side is 1, 2, 3, 4, 5, 6. So I multiplied each side by 2, and I can do that here too. I could find the distance that's doubled. Here I can find the distance 1, 2, 1, 2, 3, 4, that's doubled. So it in fact gets bigger by 2. So it has to lie in the same line and have some sort of scale factor. It has to be multiplied by the same number on all 3 sides, or all 4 sides, depending on what the figure is, okay? Okay, so we're going to find the dimensions of figures after dilations, okay? So if I look at this very beautiful picture, okay, they want me to find the scale factor, okay? Now remember earlier, a few minutes ago, we talked about the scale factor, and we had this very complicated way of explaining it, right? But basically, I'm looking at this picture frame, right? Again, a picture inside of a picture frame. And I want to know the scale factor. So I'm going to take the length of the picture frame over the length of the picture to find it, okay? Basically what, in very easy terms, I'm taking the new length, okay, over the original length. So the picture is the original length, the frame is the new length. So let's do some counting here. So I'm actually going to count this. The length of the picture is 1, 2, 3, 4, right? So the picture is 4, and the frame is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the frame is 8. Now I wrote these numbers off to the side for myself, but you can't see that at the moment. So the picture is 4 and the frame is 8. And the scale factor, okay, is going to equal the new length, and the new length is the frame, okay, which is 8, over the original length. The original length is the picture, which was 4. And I'm going to divide that. 8 divided by 4 is 2. So the scale factor is 2. So if I multiply each length of the picture by 2, I'm going to get the length of the frame. Okay. All right. Another example here. Miss Husbeck is making pancakes on a griddle. At first, the pancake batter forms a 4-inch circle. So if I look at this, my circle is 4 inches across. There's my pancake. It flows, so remember, as you pour pancake batter, it gets bigger and bigger, right? It becomes a bigger circle, so it's some sort of bigger circle around here, right? They tell me the scale factor of the dilation is 1.5 centimeters or inches in diameter, okay? They want me to find the diameter of the whole pancake once it's all spread out. So it was originally 4 inches, right? And since they give me the scale factor, the last question I had to find the scale factor. This time they give me the scale factor is 1.5. All I have to do is 4 times 1.5 to find the new length of my wonderful pancake here. And my brain is absolutely fried, so I'm going to get a calculator out just to make sure I'm doing this right. And 4 times 1.5 is 6. So it is now 6 inches across, okay? So we got a pretty big pancake. So if you're trying to find the scale factor, you got to do the new length over the original length. If you're trying to find a length, you have to multiply it by the scale factor, okay? Now, different scale factors change the size of the object, but not the shape, and we've already talked about that. If the dilation is more than 1, the object gets bigger, right? And our scale factor here was more than 1. Excuse me. So my object went from 4 inches to 6 inches. If the dilation is between 0 and 1, or some sort of fraction that is less than 1, the object gets smaller. Whoops. This is supposed to say the word smaller, so fix that. Hopefully I'll fix that in your notes, okay? Before we print them. If the dilation is exactly 1, then the shape stays the same, because if I multiply a number by 1, it stays the same, right? So the object isn't going to get any bigger or smaller. And if the scale factor is negative, it actually goes in the opposite direction, but it's like you're multiplying by 1, okay? Or multiplying by whatever number, it just goes the opposite direction of the graph, okay? Which you'll see in the next example here. So this example, if a triangle has the coordinates 1, 1, 2, 1, and 1, 2. So I'm actually going to plot those on this graph that I gave you here. So I got 1, 1, 2, 1, and 1, 2. Okay, so I have a really teeny tiny triangle here, okay, on this cute little graph. It says it is transformed by each of the following dilations with their center at the origin O. Now origin means the center line here. And let me get a straight edge going. Okay, so what you do is, so I have my triangle here, cute little guy. My first scale factor is 3. Okay. I'm going to draw, actually I changed my mind of what I'm going to do first. So if I have a scale factor of 3, I'm going to write down each of my original points. So 1, 1, 2, 1, and 1, 2. Now when I do a scale factor of 3, I'm going to multiply each of my x's and y's by 3. Okay, so not too difficult. So 3 times 1 is 3, and then 3 times 1 is also 3. So I just did 3 times 1, 3 times 1, 3, 3. 3 times 2 is 6, 3 times 1 is 3. 3 times 1 is 3, 3 times 2 is 6. So the dilation of this triangle, instead of at 1, 1, like here, I'm going to plot 3, 3. So 3, 3 here, 6, 3, and 3, 6, okay? Now if I look at this, this actually lies on the line. If I line it up at the origin, I have my pretty little line here, right, that we talked about. And then if I do it through the A and A prime, again, I get this cute little line at the origin. And notice that's how that all works, right? Because I told you dilations can only be when they're all on the same line together, so that's at the origin. And all I had to do was multiply the points by 3 and I came up with it, right? Now the next scale factor is -1 here. So let's see what happens to the points when I multiply by a -1. Sorry, I'm trying to zoom out here and it's being fussy. So I'm going to multiply my original points by -1. So I'm going to get -1, -1. I don't know why it's so dark all of a sudden in here. I'm not really sure what the problem is. And then 2, 1 is going to be -2, -1. And then -1 times this is going to be -1, -2. So in case you can't see these points because I wrote them in pencil, I'm not really sure why. They were just the points that I started with here. Okay. All right, so I'm going to plot my new points here. So -1, -1, -2, -1, and -2, -1, and then -1, -2. And you can see my triangle here. It's an itty bitty triangle. And notice this is what I was talking about when the scale factor is negative. It just goes in the opposite direction of what we started in, okay? So if you look at the lines going again, it goes through all this stuff, right? I'm sorry, it actually goes through this one. And it actually just kind of continues those lines I started earlier. Okay. Oops. My drawings are a wee bit off, so that's okay. Alright, so if you zoom in a little bit, you can see my original triangle was this little baby one right here in pink. I don't know if you can actually tell it's pink in the video, but it is. My scale factor of 3 was my cute little blue guy here. And I don't have another cute color. Oh, there we go. Here's the red one here. Okay. And my red triangle was the -1 scale factor. So, if you're given coordinates, or even side lengths, you just multiply them by the scale factor and redraw them, okay? So not too difficult. Your homework is questions 1 through 5 all. Hopefully this goes well for you. Have a wonderful day. Bye.